Hello students, welcome to the part 5 of the online classes. We are continuing with the matrices, and today's topic is symmetric matrix and skew-symmetric matrix. Symmetric matrix and skew-symmetric matrix. Now, for that, we need to know what is symmetry. What is symmetry? Symmetry is nothing but if you draw a straight line to any part, the both halves are equal. For example, let me take a banana leaf. Now, as you can observe, this is the middle line, matrix. This is the middle line. The parts on both sides are equal. The parts on the both sides are equal. Next, we'll take the example of this leaf. This looks like a heart shape. You can observe. See, this is the midline. The part on both sides are equal. You can observe they are equal. So symmetry means you draw a straight line. The parts on both sides are equal. Coconut leaf. So you draw one middle line, two parts. Next, let me take a tomato. You know what is a tomato. Now I will cut this in a straight line. in the middle. I will cut this. Now you can see both parts are equal. Both parts are same. So symmetry means if you draw one straight line in the middle, both sides are equal. Next, one best example is human body. You draw one straight line in between, the both halves are equal. Like for example, draw one straight line between the face. Both sides, you have one eye this side, one eye this side. One nostril this side, one nostril this side. One ear this side, one ear this side. Also, your brain also. There is left brain and right brain. Both there are, if you draw a line in between, there are two parts. So if you have brain, you will know. Okay, so you know what is symmetry. You draw one line in between, both sides are equal. Now what is the meaning of symmetric matrix? In a symmetric matrix, by direct observation you can see, you know what is a diagonal. This is the diagonal. 298 is the diagonal. Now observe the diagonal. If this is a diagonal, the elements on the opposite sides. What are the elements on opposite sides? You take 1. The element on opposite side is 1. They are equal. Next, 9. If you take 9, which is the element on opposite side? 5. They are equal. 5 and 5, they are equal. Next, if you take 8, what is the element on opposite side? 8. They are equal. So, just by looking at the symmetric matrix, you can see if you have a diagonal in between, the elements on opposite sides are equal. Mathematically, we say a matrix A is symmetric if A dash equal to A. What is the meaning of A dash? A dash means the transpose of a matrix which is got by exchanging the row and column. You make the row into column. That same is same as A. So mathematically we will see. Now we have example, take this matrix. This is definitely a symmetric matrix. I told you how the elements on either side of the diagonal are equal. 1 equal to 1, 5 equal to 5 and 8 equal to 8. Now take A dash. What is A dash? Write the row as column. So which is the first row? 2, 1, 5. Write it as column. 2, 1, 5. Next row is 1, 9, 8. Write it as column. 1, 9, 8. Next is third row 5, 8, 3. Write it as column. So as you can observe, A and A dash are equal. So A dash equal to A. Therefore, A is symmetric. I hope you understood what is symmetry. You draw one line in between, both sides are equal. So here if you draw one diagonal line, on both sides the elements are equal. So that is the symmetric matrix. meaning of symmetric matrix. I hope you understood what is a symmetric matrix. Next we move on to skew-symmetric matrix. Skew-symmetric matrix. It is same as symmetric matrix but negative. Negative. Skew means negative. So A is said to be a skew-symmetric matrix if A dash equal to minus A. A dash equal to minus A. Same as before, here A dash equal to minus A. Negative of the matrix. Now, one more important point to notice. In this skew-symmetric matrix, all the diagonal elements are 0. All the diagonal elements are 0. So, look here. Example for skew-symmetric matrix. Here, diagonal elements are 0. Diagonal elements are 0. Next, what about the elements on either side of the diagonal? You see 3 and minus 3. The elements are negative of each other. They are same but negative of each other. So 3 and minus 3. This 5 and minus 5. 5 and minus 5. Here 6 and minus 6. So you understood the difference between the symmetric matrix and skew-symmetric matrix. In the symmetric matrix, the elements on opposite side of the diagonal are equal. Here they are negative of each other. Here they are negative of each other. If there is 6, the other one will be minus 6. So here 3, then it is minus 3. Minus 5, then 5. 6, then minus 6. I hope you understood what is a skew-symmetric matrix. Now, mathematically we will try to get the value. Take the transpose, means write the row as column. So 0 minus 3 5, 3 0 minus 6, minus 5 6 0. Now look at this. A dash equal to minus A, we have to get it. Take the negative outside here, take minus 1 outside. When you take minus, what happens? If you take minus, so minus of minus 1. 1 is nothing but minus of minus 1. So when you remove minus 1, the sign changes. When you remove minus 1, the sign changes. So take minus, here the 0 is same. Here the sign changes, minus 3. Here when you take minus outside, the sign changes. When you take minus outside, the sign changes. So take minus outside, sign changes. Here 0, 0 is next. 6, when you remove minus outside, the sign changes like this. So minus 6. 5 is positive. So when you take minus outside, the sign changes. Minus of minus 5. So minus 5. 6, we are removing the minus outside, so 6, 0 is 0. So if you observe, this is nothing but A. This is nothing but same as A. So this is nothing but minus. So in a skew-symmetric matrix, A dash equal to minus A. In a symmetric matrix, A dash equal to A. So that's the difference. You know what is the difference? In a symmetric matrix, above the diagonal, the elements are equal. In a skew-symmetric matrix, above the diagonal, elements are negative of each other. Negative of each other. So this is symmetric matrix and skew-symmetric matrix. Next we move on to the seventh question. Seventh question, show that A is symmetric. So you know how to show it is symmetric. If there is a diagonal, the elements above and below are equal. So here you observe minus 1, 5, 5, 1 and 1. So it is definitely symmetric. How do you show mathematically? Take A dash. What is A dash? Write the row as column. 1, minus 1, 5. Write it as column. 1, minus 1, 2, 1. 5, 1, 3. So A dash and A, they are same. So A equal to A dash. Therefore A is symmetric. So therefore A equal to A dash. Therefore A equal to A is symmetric. So A is symmetric. Next, Sub question 2, show that this is Skew-Symmetric. Of course, you know it is Skew-Symmetric because the diagonal elements are 0. The elements on opposite side, they are negative of each other. They are negative of each other. So 0, 0, 0, minus 1, 1, 1, minus 1, minus 1, 1. So it is Skew-Symmetric matrix. Mathematically, how to show? Take A dash equal to, write the row as column, 0, 1, minus 1, minus 1, 0, 1, 1, minus 1. So take the negative outside. When you take negative outside, the number sign changes. So 0, it is no sign, minus sign changes 1, here sign changes minus 1, 1 sign changes minus 1, 0 sign changes 1, sign changes 1, minus 1. So this matrix is same as A. So therefore A dash equal to minus A. A is, so A dash equal to minus A, therefore A is Skew-Symmetric. Next we move on to the 8th question. For a matrix A 1, 5, 6, 7, verify that A plus A dash is a symmetric matrix, A minus A dash is a Skew-Symmetric matrix. Now we have to get A plus A dash. So you know what is A dash? Take the transpose, write the row as column. So row 1, 5, write as column, 6, 7, write as column. Now we have to get the A plus A dash. A plus A dash. So what is addition of matrix? Addition of matrix is nothing but add the corresponding first element with the first element, second with second, third with third, and fourth with fourth. Now add 1 plus 1, how much? 2. 5 plus 6, how much? 11. 6 plus 5, how much? 11. 7 plus 7, how much? 14. Now is this symmetric? Is this symmetric? Definitely, because you see the diagonal element. What is the element on opposite side? 11 and 11, they are equal. So definitely, or you can take its transpose, A plus A dash transpose. Take the transpose of this matrix, what you get? Write the row as column, 2, 11, 2, 11, 11, 14. So it is definitely same as the original matrix. Therefore, A plus A dash is symmetric. Next, take A minus A dash. A minus A dash. Take A minus A dash. What do you get? 1 minus 1, 0. 5 minus 6, minus 1. 6 minus 5, 1. 7 minus 7, 0. So it is definitely a skew-symmetric matrix because the diagonal elements are 0 and the diagonals above and below the element are minus, negative of each other. 0, 0, 1 and minus 1. Or take its transpose. Take its transpose, what you get? When you take negative sign outside, you get? So it is same as minus 8. So take A minus A dash, 0, 0. When you take transpose, what you get? Write the row as column, 0, 1, minus 1, 0. Take negative sign outside, the sign changes, 0, minus 1, 1, 0. It is same as the original matrix. So therefore, it is A minus A dash equal to minus A minus A dash. So A minus A dash, the whole dash equal to minus of A minus A dash. So therefore it is Skew-Symmetric.